Hello, good day. I'm Jasral Tadjagarin from BES in A1A, and this is our RVR number 4. And I already write my answer in problem 1 to 3 to easy understand, and for now, I will explain how I got it. Problem 1. Wheel is rotating about an axis that is in the two direction. The angular velocity W sub c is negative 6 radian per second. At time equals 0 second increases with time, and is positive 4 radian per second at time equals 7 second. We have taken counterclockwise rotation to be a positive, and question letter A, is the angular acceleration during this time interval positive or negative? So velocity or W sub c increases linearly with time, where t is time and second, and W sub c is the angular velocity in radian per second. Therefore, the slope between the given points is we need to find. So 4 negative times negative 6 over 7 minus 0 equals 10 over 7 radian per second square. And find the linear equation of angular velocity in terms of t W sub c equals mt plus b. So angular velocity equals 10 over 7 t minus 6. So when the angular velocity is 0, the time is 4.2 seconds. In A, angular acceleration equals d W sub 2. In A, angular acceleration equals d W sub z over dt equals d over 7 radian per second squared. Therefore, angular acceleration is positive in time interval. And also, the angular acceleration is equals to the slope, because between angular velocity and time are a linear relationship. Question in letter B. During what time interval is the speed of the wheel increasing or decreasing? As we can see in the graph, A, which is x is 0 and y is negative 6, and v is x is 7 and for y is 4, and c 4.2 and 0. And in points A and C, angular velocity is negative and the angular acceleration is positive. Then angular velocity is decreasing at the time interval 0 less than or equal time less than 4.2. The wheel is turning clockwise with angular velocity is equals to 6 radian per second at time is equals to 0. But it rotates slower and until angular velocity is equals to 0 at time equals to 4.2 seconds. And in points C and B, where angular velocity is positive and angular acceleration is also positive, it is increasing at time interval 4.2 less than time or less than or equal 7, and it rotates counterclockwise faster from angular velocity is equals to 0 at time is
equals to 4.2 second until angular velocity is equals to 4.4 radian per second at time is equals to 7 seconds. So therefore the speed of the wheel is in letter B is decreasing for 0 less than or equal t or time less than 4.2 and increasing for the 4.2 less than time or less than or equal 7. And letter C question, what is the angular displacement of the wheel at time equals 7 seconds? Since angular velocity is equals to d theta over dt, to find the angular displacement, we use d theta equals to w sub c dt. So, integrals theta 0, d theta equals to integrals t 0 times t over 7 time minus 6 times dt implies theta equals to 10 over 14 t squared minus 6t. Theta times 7 equals to 10 over 14 times 7 squared minus 6 times 7 equals negative 7 radian. So, therefore, the angular displacement at time of 7 seconds is negative 7 radian. Problem number 2. Three forces are applied to a wheel of radius 0.350 meter as shown in figure. One force is perpendicular to the rim, one tangent to it, and the other one makes a 40-degree angle with the radius. So, question. What is the net torque on the wheel due to these three forces for an axis perpendicular to the wheel and passing through its center? In figure, as we can see, the F sub 1 is equals to 11.9 Newton and F sub 2 is equals to 14.6 Newton and F sub 3 is 8.50 Newton and for the radius is 0.350 meter and the angle is 40 degree. For torque, the expression is equals to torque equals RF sine theta, where F is the force and R is the distance. So, the equation of net torque is given. Net torque is equals to torque sub 1 plus torque sub 2 plus torque sub 3. So, from the diagram, net torque is torque equals to RF sub 1 sine theta sub 1 plus RF sub 2 sine theta sub 2 plus RF sub 3 sine theta sub 3. Well, we substitute the value, which is 0.35 meter for R, 11.9 Newton for F sub 1, 14.6 Newton for F sub 2, 8.50 Newton for F sub 3, and 0 degree for theta sub 1, and 40 degree for theta sub 2, and 90 degree for theta sub 3. So, ito siya. Nung sinubstitute natin, then, kitang-kita na rin natin na cancelled out na to kasi ito tayo siya. This is 0. So, yan na nga. Since na-substitute na natin, well, we 14.6 Newton times 0.35 meter times sine 40 degree plus 8.50 Newton times 0.35 meter sine times 90 degree. So, the torque net is equals to 6.26 joule Thus, the value of net torque is 6.26 joule. For the last number, which is the problem number 3, find the magnitude of the angular momentum of the second hand on a clock about an axis through the center of the clock face. The clock hand has a length of 15 cm, a mass of 6 grams. Take the second hand to be a slender rod rotating with a constant angular velocity about one end. So mass is the given is 6 grams. Then the length is 15 cm. So now, ito yung ginamit ko para i-convert yung mass sa kilogram. So 6 times 1 divide 1000, which is 0.006 kilogram. Then sa length naman is kinonvert ko siya into meter. 15 times 1 divide 100, which is 0.15 meter. Ito yung ginamit ko. So next is moment of inertia for the clock hand is given. So length is equals to inertia is equals to mass times length squared over 3. So substitute natin yung value, which is 0.006 times, kaya ito lang na pala ito, 0.006 times 0.15 squared divide 3 is equals to 4.5 times 10 raised to negative 5 meter times kilogram. So for the angular velocity naman, which is the given formula is angular equals to 2 phi over 60. So given na to yung value ng phi, which is 2 times 3.1416 divide 60 is equals to 0.10 0.10472 radian per second. So to get the angular momentum, which is may mga value naman yung sa formula ng angular momentum, so equals to inertia and angular velocity. So substitute lang natin siya, which is yung sagot dito and yung sagot dito, yung value nila. So substitute lang natin. 4.5 times 10 raised to 5 times 0.10472 is equals to 4.711 times 10 raised to negative 6 kilogram meter squared per second. So therefore, the magnitude of the angular momentum of the second hand on a clock about an axis through the center of the clock face is 4.711 times 10 raised to negative 6 kilogram meter per second square. So that is our last problem. Then thank you.